Hi, Mario.
Hey there, how are you? All good?
Good, good. You?
All good.
Awesome,
Excited
awesome.
for today.
Yeah,
Very
me
excited.
too. Me too. Hello, everybody. We will wait some time so everybody can join us today. And today it's about opening up the engine about Enigma. So we will talk about the architecture, the cryptography, and the real world constraint around it, with which basically we build Enigma. We also explain the licensing as well. But the core, of course, topic is the technical transparency. So we would like to explain what Enigma is, basically. So how are you, Mario?
I am doing very good, very excited to share all of the stuff that we've been working on at all the detail that I can possibly share. And just a quick shout if you still have questions regarding like how Enigma works and everything. All of this is peer reviewed and we have this like the papers are published. We can post the links here as well. So then you can actually dive into every single little math detail that I hopefully cover on the GitHub as well. Worst case scenario, feel free to send me a DM on Twitter or X now, and I'll do my best to get back to you ASAP. So very excited to share everything because we've put in a lot of work into this.
Yeah, absolutely. And I think it would be good to introduce ourselves because maybe somebody is not yet aware of who we are. So we'll start with myself. My name is Salvaja. I'm the product manager leading the permissioned private side of Rails. I'm working and focusing mainly on privacy and enterprise adoption, with a decade of experience around technology, enterprise architecture, and privacy. And with me today, we have Mario, that is our head of research.
Yeah, so Mario, cryptographer by trade, head of research at Parfin, so the core contributor of Rails. I've been doing like a lot of cryptography work in the past. You may even have seen some of my work recently cited by Vitalik and others. Doing my best here to bring privacy into the real world so that we can all benefit from very strong, usable mathematics in our favor.
That's great. That's great. And as Mario said at the beginning, we are open to questions. So please share your questions. And even if you have after our space today, we always open to hear your feedback, hear your questions, and answer them as quickly as we can. So maybe we can start thinking and talking about Enigma. And so what I will have to ask you, Mario, is what problem does Enigma solve that existing privacy solution don't?
That is a great question right off the bat. The rationale for Enigma was actually very interesting because as we were talking with financial institutions, and just a quick shout here because we in our research side we always follow what's happening in the cryptography and cryptocurrency space, seeing what's like the pedigree, state of the art private transactions mechanism. But as we were talking with financial institutions, we noticed that there was a bit of a gap between what was out there for people to use and what those financial institutions actually needed. All right, and I'll dive into a bit more detail there. But for example, it is very important that if there is an auditor involved, that there should be a specific view key, right? So there should be a separation of roles. So if you have a key to view transactions and a key to spend transactions, this is often used in many protocols, as many privacy protocols out there, but it's also not used in many others, right? So right off the bat, you're already discharging, like letting some of them go. Then you also have this very strict requirement of, since you're dealing with kind of like reinventing money, you need to think almost in like a decade's timeline. And so one of the things that was brought up right away was the security against quantum computing. And obviously that unfolds into two pieces. Kind of, you have like the notion of quantum privacy, which already, if you're familiar with the space, already implies like using zero knowledge primitives, but then also quantum security, right? So kind of like how can you have the entire stack at some point that you just like quickly transition into full quantum secure primitives without actually influencing the performance of your design a lot, right? So like that's just a couple of like quick glimpses there of the things that were thrown at us. Uh, but as we explain how the protocol works, you will quickly see that there's a lot of specific reasons why things are designed in like very peculiar, specific ways, right? So, and again, if you have questions, feel free to like post and DM us. But most likely, if something looks a bit peculiar, there's a reason why it's done that specific way. I'll put it that way.
We had a lot of conversation around this. And what I want to say is for like the definition of what privacy is, I think one of the best that I read was in the Project Epic by JP Morgan, where we are cited as well for our solution. And there is like the explanation on privacy around confidentiality and also anonymity, and have both of them together with scalability and auditability as well. So I would like to ask to you how confidentiality and auditability coexist in Enigma today.
Yeah, and this is actually one of the things I even love about the spec for Enigma is that we made it very modular. As we were talking to financial institutions, we realized that there's like a very important role of an auditor in the system. But it's also the case where in specific deployments, you don't necessarily need an auditor, right? So the way we design Enigma is to have those two modes of operation. So like you can either quickly integrate an auditor and give it almost like as much viewing as you wish within the system. So if you want the auditor to see just a single transaction, that's possible. If you don't want a single auditor, have a specific setting where you don't need auditing, that's also possible. If you need an auditor with like specific views of a specific token, that's also possible. All while achieving confidentiality and anonymity against every single other entity in the network, right? So this is kind of like a very important thing. And imagine, just think about it this way: say I'm selling a car, I want to make a private transaction, but maybe the DMV or like the department of that has issued that car, they just need to know who is the new owner of that car, right? So like they audit that specific transaction, and we have full support for that. And obviously, keeping in mind what I just mentioned, we have this notion of view key and spend key, right? So like we can give the auditor either an ephemeral view key, a long-term view key, that there's different types of view keys, but the auditor is never able to spend money on your behalf, right? So that's kind of like the most important thing. And I honestly think that whenever we talk about Enigma, this is the most asked question is the auditor able to spend funds? And the answer is always no. The auditor
Yeah.
is not
And
able
they,
to spend funds. They have some type of visibility depending on how exactly Enigma works in that setting, right? And the beauty of Enigma is that you can instantiate it in a lot of different settings, and that's why most often the answer is kind of it depends, because you can change it. It's almost like a little set of it's a Lego box, right? You can kind of change it a bit, and then it works for a lot of different use cases, which is great, but sometimes like bad because you just want to see it in a specific way. So that's why I'm trying to keep the examples like very precise so that you can have an idea of exactly how it could work.
yeah. And you can work in different jurisdictions, for example. So if you can have an auditor for each one of them, and you can decide what to. The auditor can be also the issuer of the token itself, so to keep control over the assets. Um, the other part that I think it's quite important is like all the cryptography behind the product. So all the items that together with this two different keys, the spending key and the view keys, are helping with keeping Enigma safe and private, basically. So and you will explain how homomorphic encryption, ZK proof, the private message tagging work together on a high level.
Yeah, this is probably the most exciting part of the AMA for me, right? Because I get to actually dive deep into this. So the first thing to keep in mind here is that we have this notion of a privacy node, right? So like this privacy node is a high performance uh, blockchain, and think of it as a financial institution, right? So like the financial institution runs this privacy node, and this privacy node is very fast, which allows the financial institution to process a lot of transactions for the users, right, everyone? So kind of like that's the main takeaway. And I like to use this like a helpful mental model. It's not 100% like the same, but a helpful mental model would be, think about it almost as like an L2 with specific design constraints, like a very fast L2 that is not publishing things onto the underlying layer one. There's some caveats there, but if you're familiar with that type of architecture, that's how I like to use as a reference. So those privacy nodes are going to be the entities transacting. And you may think like, oh, that's amazing because then they have a lot of hardware and you can kind of have like a lot of very expensive things. But you would be surprised at how that's actually not true. So sometimes the hardware requirements for some of the financial like institutions are not what you would expect, comparable to other things that you see out there in the cryptocurrency ecosystem. And again, very concretely, just so you have an idea, I've literally seen other people demand like 128 gigs of RAM, uh, like 16 cores of compute, and machines that are very expensive, and many regional banks don't have that type of compute, right? So we cannot really have a system that depends on that. So like the first thing we focus on Enigma is, all right, let's have like this be a very interesting trade-off. And again, when you think engineering, it's always a trade-off game. So we wanted obviously to pass a bit of compute to the privacy node because most likely they have more power than the actual user. User is probably just on their phone, although phones are very powerful today. They're still not very great for ZK stuff. And then we want any type of zero knowledge proof of validation to take place on what we call the private network hub. So like that would be like almost the equivalent in mental model wise of the layer one. And we want the ZK proof verification to take place there. And we want that to be as light as possible. So then if you're familiar with ZK, the most like obvious choice in the room was to use a scheme called Groth 16 because verification is constant time. So that was like very useful to have there. All right, so now that we have the privacy node, we have this notion of, okay, all of these privacy nodes are connected to this like private network hub, right? It's literally like a hub there where people post messages. So now we have this notion where all of them are posting messages, and I like to think of it as like post-it notes. Like all of these privacy nodes literally write the message on a post-it, and they post it there on the private network hub to see. So think of it almost like probably the fridge that you have in your house, where the family members are leaving messages to each other. They put like little post-it notes there on the fridge. Now the problem with using these post-it notes is that everyone is seeing that same fridge, right? So like if you want to keep some things private, you cannot really say like, hey, bank B, here's money from you for you from bank A. So now we need to add encryption to those little post-it notes. So it's like that's kind of like how the whole magic then starts to happen. And then you go, all right, but how are we actually encrypting these things? Right. And if we go back to what I was saying a bit earlier, is how can we have this quantum private? So if we want quantum privacy, that's already the first challenge there. Is okay, let's use symmetric encryption. Perfect, that's quantum secure. All right, but how are we getting that key to encrypt those messages like that way? How are we getting the symmetric encryption key? We need a key exchange or a key agreement before. That key agreement now has to be quantum secure, right? And since we're dealing with financial institutions, we chose to use what is known as the MLKM standard. So that would be a NIST-approved key encapsulation mechanism, which is what the KEM would stand for. So that would be like step one. So we have these privacy nodes, they have that key, they publish it there. And now you already see how like now these post-its that are posted on this chain, now they're encrypted. Perfect. You're like, okay, that makes sense. You don't really know who is transacting with who. But you still have an issue, and this is actually like a big issue in the cryptocurrency space in general, is all right, so then these banks need to be able to get these post-it notes. And a big issue that exists today is imagine you go to an RPC, so you actually go to like a node to ask for these post-it notes, and you say, I want post-it note number 5. Then the RPC or the full node is going to be like, okay, this is so interesting. This specific bank is asking for the post-it note number 5, which was posted by this other specific bank, right? So even though mathematically you have what seems to be a very secure end-to-end flow, that specific query just asking, like, I want this specific post-it, is probably breaking the entire anonymity in the process, right?
It's revealing
So what
information anyway.
it's exactly, so it's revealing a lot of the information, and it just comes to show how the devil is in all of these little details, right? So you may have something that is super sane, like super good end to end, but then that specific query to the node gives everything away, right? So then we have this notion of the private messaging tags. So now you post all of these, you put a lot of post-its on this uh, blockchain, and then when you query the node, you actually query for a lot of them. So you and these the private messaging tags are very small, all right? So they're, if you want to be pretty technical, they're just a hash there. So then you download these ones. The node no longer knows which ones you're exactly fetching for because you're actually downloading a bundle of them. And then once you have them locally in your own machine, you can go, okay, out of these transactions, which one is for me? And at that point, you're already good, right? Because you're doing like your lookup is local, and this is it's called private information retrieval. And the easiest example of private information retrieval, if you want to think about it this way, is imagine you go on Netflix, you want to watch a movie, and you type whatever, Christmas Miracle. Netflix knows, all right, Mario is watching a Christmas Miracle movie. You could technically download every single movie from Netflix onto your computer and then just do that lookup locally.
Yeah.
But that's not really practical, right? Imagine downloading every single movie from Netflix. So that's not really ideal. Uh, so that's the equivalent of what we're trying to do here, but with very compact tags. So like if you think end-to-end flow, we have these privacy nodes. They create a private transaction. The private transaction is going to have this private messaging tag. It's going to have a set of commitments, a zero knowledge proof, and a nullifier. That is all going to be posted on the blockchain. Blockchain is going to verify it. They're going to check that a couple of things are correct there. This is described in a lot of detail in the GitHub, in the papers. I can talk a bit about later in the AMA. And then once that's done, the privacy nodes then fetch all of that, and they can do that lookup and see what money they have there for them. And now the key thing here is the entire flow is quantum private. And the only thing left to make it completely quantum secure is to just use post-quantum zero knowledge proofs. And we're already benchmarking that. We're just trying to figure out exactly what is the best scheme for this specific design, right? But it's very elegant in the sense that everything already works with very high performance, and that's the only thing that we have left to change. So if you're a bit more technical, like complexity wise, everything is at most linear in terms of compute. And it's either linear in number of participants, so like participants in this case, it's number of banks, or linear in terms of token transactions amongst those banks. So it's all nothing is quadratic, which is usually when things kind of like go wrong. Everything is at most linear, but even most of the things are constant, which is it's good. Usually constant complexity is very good. I hope that answers the question. I tried to
Yeah,
kind
it
of like
does. It
explain this
does.
whole flow, maybe in a bit too much detail, but I think it's also a sign that you see how excited I am with
No,
this.
that's good. That's good because we wanted to go to the core, technical architecture and information around all the tools that we are using basically to ensure a complete privacy preserving solution. Another thing that I believe is still part of the architecture is the EVM compatibility, right? So we built that to work, of course, with Rails and together with Rails, but the compatibility can actually go further than that. So what I would like to ask you is why EVM compatibility matters for adoption.
Yeah, so we quickly realized that EVM is almost like the de facto standard for this type of tokenization, and all of the pilots are, or most of the pilots that are taking place right now. And it's also the case where you can probably just transpile from Solidity to something else if you need to. So EVM ends up being like this safe haven or safe harbor of how to do things. And you would be surprised at how often that's actually like a relief when you're talking to a counterparty and they go like, "Oh, is this EVM compatible?" And you're like, "Yes." Like everything was thought from the start to be EVM compatible, and our entire stack is EVM compatible and Ethereum aligned, right? So when you think Enigma, you think EVM. Like that's the, and even if you look at the repo itself, you're going to see like the Solidity smart contract there, the ZK verifier there, like everything is EVM, and that matters a lot for adoption because the moment these pilots are being run on this EVM foundation, and we allow this plug and play privacy framework to exist, then you're basically fast tracking the adoption of privacy, right? Like it's just the fact that you can just go, listen, you have that exact same infrastructure, just plug and play this onto what you already have. You don't really have to make a lot of changes, and you'll be able to have private transactions with specific auditing requirements, like you name it, and you can probably just tweak this to fit what you need, right? And we've been getting very, very good feedback. Institutions are loving it, and it seems to kind of like check a lot of the boxes of the requirements that we've been given in the last couple of months, if not years even.
Yeah. Yeah, we'll do also like a small spoiler that we are testing Enigma also on our public chain. So we are trying like using Enigma also on the other chain that we have, and I think it's quite interesting because this it's opening the idea of Enigma not only to institutions but also to retail and crypto users who that can interact and understand the code as well, since from today it's open, so everybody can go and look at this and try, and please let us know feedback and everything else. But this is really opening up Enigma and the transparency of it, and the verifiability as well. Like try to verify what we are saying right now. The security, the performance, the as well as the privacy preserving solution. And all these small, as you said, the devils is in the details, is basically all the small things that we took care of to consider, the small things that could reveal information, even small ones, but could destroy completely the privacy preserving solution, either confidentiality or the anonymity part of the overall solution. So this is also quite important because we started working, of course, on Enigma for institutions, but institution has like a very complex technology architecture and enterprise architecture where you need to be compliant and they are regulated. So you need also to comply to that. How you think Enigma works well with this overall very regulated environment?
I mean, that was probably the biggest hurdle we had to overcome, right? Because it was so challenging, but also so rewarding because I remember every time we were thrown a list of requirements and we actually checked all of those requirements, then the financial institutions got so excited and they threw more requirements at us. They'd be like, "No way, you can do all of that. What about these things?" And it sounds fun now that we actually overcame all of that and we have something that works very well and it's very I like to think of it as like very clean and elegant in terms of like a protocol, but It was also very frustrating because we like obviously these are like there's a lot of back and forth and there's a lot of discovery going on right now into what you can actually achieve, what is possible, and there's even projects that claim that that's the best you can achieve, and that's not necessarily true because again, at the end of the day, there's a lot of trade-offs, and it, probably the what you actually need is just a specific trade-off decision that works well for you. Uh, so I love that Enigma works very well for that because every time we were given requirements, we fulfilled all of them. We were given more requirements, and we now have a protocol and a design that is so flexible where you can choose your own trade-offs, right? And I think that's so powerful. It's not just kind of like a fixed menu where you go, listen, here's this is how it works. It's actually something where you go, all right, here's a menu, there's a couple of pages there, see what works best for you. But maybe we can also talk to the chef if you need to have like some extra changes there, right? And that's probably what you want, even whether you're going to a restaurant or trying to deploy something yourself, is every case is its own case, and every institution and every jurisdiction has their own set of rules, right? So kind of like this one cut approach to fix everything doesn't really work. And with Enigma, we tried on purpose to keep it very flexible. And the auditing, for example, is like a very good kind of like example of that, like exactly. Like there's lots of different types of auditing that can take place in the system, right? And sometimes it's even a bit frustrating because like other projects claim they have auditability, but then it's very obscure to see how that even works, right? But then if you go and look at our spec and our documents, you will see that we have like three or four different types of auditing, who they're designed for, uh, what entities, what can you see, what are like the traits, how do we ensure quantum privacy? So like you actually, is there more than one auditor? Like that actually may be the case, right? Like then people rarely talk about that. There's probably more than one auditor in the system, right? Like maybe the issuer needs to be an auditor, and there's like an official auditor there. Uh, we support for that, right? And I think we worked very well on fitting that specific side of things for institutions.
Absolutely. So we have the possibility to audit, so it's aligned also with compliance. The other thing that I believe it's worth to mention is, especially if you use Enigma payment. So Enigma is like an umbrella for different privacy, basically protocols that we have. We have the payment side, we have the DVP side, and many more to come. The idea of the payment and the ability that we have there is also, keeping control over the issued token, although keeping privacy to whoever would like to transact with it. So the sovereignty of the token itself is still under the user issuer, basically. So they can also always know what is happening at the higher level and have control over the total supply, without anybody else being able to either burn or mint new token on their behalf. The other great thing is like we work with different institutions, right? We work with the Central Bank of Brazil, we work with other FMIs like Nuclea. We recently participated also some of the challenges of the Bank of England, that by the way, we will talk about it tomorrow in another Twitter space, X space, sorry. And there is also, so all this work that we did with them is like for us, we're able to understand a little bit more about their legacy system, how to connect Enigma. And another thing that is quite important is like Enigma, it's based on a messaging system. There's kind of this standard that is used inside the legacy system today. So whoever is receiving the information can always handle the transaction as well. What I think is really interesting, Mario, if you can guide us in some of the use cases, maybe the CBDCs one or others as well, so we can understand a little bit more like practically how to use Enigma.
Yeah, and I want to touch on this again because it's very important. So we have think of it in Enigma as like the whole framework, right? Like Enigma is the umbrella, and inside Enigma, you're gonna have two protocols. You're gonna have Enigma payments, which is designed for financial institutions to settle uh, financially with each other, and you're gonna have Enigma DVP. Enigma DVP is very, very interesting. It's not the scope of this AMA, and it will be open source and like everything published like very, very soon. We're trying to get the peer-reviewed papers out of the door now. But like a DVP is a delivery versus payment transaction. So it's like an atomic swap of think of it as an NFT and money. And we have very interesting things there. Uh, think like buying a car and the atomic swap like takes place immediately and privately, right? So this is actually like a very interesting thing. While many institutions are still trying out normal, transparent DVP uh, transactions, we are already benchmarking private DVP transactions with some of these central banks, right? So like that's how powerful Enigma is. So like only now some people are trying out like basic DVP. We're already solving a lot of the issues there. So keeping it focused. So today we're talking Enigma payments, and Enigma payments is for financial institutions to pay each other. And there's a couple of interesting things about Enigma. And the first thing is it allows banks to pay each other atomically in a single block. And not only pay each other, they can actually pay multiple banks all at once. And this is a property I love. And I'm even going to expand on this property even more. But the first thing is a bank can pay like five other banks all at once in a single block, and the cost of that transaction is the same, gas wise. Um, the reason there is because we can aggregate a lot of transfers into a single one, and then checking it, like the ZK proof checking, is exactly the same. An important thing to mention as well that I think is often overlooked is that we actually benchmark this on a very vanilla Mac Mini from like 2021, maybe 2020, and the transaction takes less than half a second to create. And when you think like ZK, usually like the zero knowledge proof generation takes a
Very
lot.
heavy. Mm.
And often when it doesn't, it's because it's using a very powerful computer. But here we purposely used a very vanilla Mac Mini, and we have those benchmarks on GitHub because we knew how important it is to have this accessible for the public. Like not everyone has access to those very expensive AWS machines uh, to have like a 2 second proof generation. So here we did our best to optimize everything as much as possible. Another thing I love about Enigma is that we support, so like we already talked about how you can pay multiple banks at once. You can actually pay multiple users in multiple banks all at once, right? So that's one of the features that I love. And think if you have Alice and Bob, they bank with Bank A, and then you have Charlie and Dave, they bank with Bank B. A single transaction can actually pay both Charlie and Dave on the other side, and then you can kind of like grow that number of users as almost as much as you want, and then pay them all different users for different banks again in a single transaction with the exact same gas cost, right? Which I find pretty nice because you can kind of like bulk up a lot of transactions there and then just pay people. I think this is one of the questions that was just thrown out here. We are doing our best to have this usable in the test net now so that you can play around with a couple of different concepts. We will keep everyone posted there, but this is something that we are very excited to have this in your hands as soon as possible. Just always keep in mind that right now the way Enigma is structured is mostly for privacy nodes or these financial institutions to pay each other. But that specific setting, you will be able to test it out and see how Enigma works. Also, the code that we just published, you can run it locally and test out. Like we have the demo instructions, we have how the protocol works, so then you can kind of dive deep under the hood, right, and see how things work behind the scenes. I think those are the most. I don't know. You tell me. Am I missing something like use case wise? Like that's
No,
the
I think
most pressing things. Like it's fast, real-time payments across financial institutions. I think that's the
yes.
most
Yes, the
pressing thing.
CBDCs specifically, the use case there is using wholesale money, so basically the central bank money. But the other items that maybe we can mention is the programmability. So on top of what the payment, like the movement of the wholesale money on our hub, on the private network hub is doing, we also have the possibility to basically create this wrap token that is like a representation of the value of the wholesale money, but in retail money. So this means that the bank can use that inside to share the value, of course, with their customers as well. And with the programmability, we had a lot of other options, like the possibility to check, viability, but also other, wealth checks or KYC check before proceeding with the transaction itself, with the settlement of the transaction. Plus also having the possibility to connect with legacy system like RTGS system, where there are real-time gross settlement system, where you have the reserves of the banks saved, and so you can send the information after the settlement occur about what happened. So basically you can update the reserve of a specific bank after the settlement of the Rails hub happened. Using Enygma, you always have the control that is like the source of truth, basically, of the assets itself. So you can share this information with the reserve in a safe way. I think I would just have this one on top of what you mentioned. So I see a lot of questions about the license, and I think we can dive into it a bit. So why did we choose the dual license model? I want to explain that. We choose that because Enigma was built to serve two very different and equally important audiences. One is the open source developers, of course, and the other side is the regulatory institutions that we discuss as well. And making the code public was not negotiable for us. So we wanted you to, for us to be transparent, but for you to be to verify what we are saying, right? And test it and give us your feedback. But at the same time, institutions need legal certainty and confidentiality when deploying critical systems. So with the dual license model, what we can do is support both the realities, give the open code basically, and give you the possibility to use the code, test it, and build on top of that. And also for the enterprise, when they want to distribute or use Enigma in one of their product and distribute that into their customers, they can do that with the commercial license. So the dual license is serving these purposes. It's helping both the world, basically. And this is also like, what does this dual license allow people to do? So you can use Enigma freely, inspect, modify, and redistribute that. And you need to keep, of course, that public if you want to redistribute that. If you want to not keep that public, what we can do is give you like the commercial license. And so with the commercial license, you can keep, the confidentiality that you need. Maybe if you have you have a specific requirements like an institution can have. Then the other thing that maybe there were like some questions about is like going a little bit more in details of what is the difference between the SSPL and the commercial license. So basically the SSPL is talking about giving the possibility to use the overall code as an open source. So basically you can use it, you can modify it, but then you have to, if you want to redistribute that or distribute that to either your customers or other people, you have to publish that and publish that and whatever is around Enigma in this case. So we wanted to keep that a little bit more flexible. And with the additional, commercial license, this is what we give the chance to use the code and distribute the code. More than use is distribute the code with the commercial license. So this is like the difference and the possibility to had both. I see also questions around and there's the one that also Mario was mentioning. can we experience this during the testnet? So basically, we are testing right now on our hand, and soon we can be able to do that. We don't have yet a date, but yes, the idea is, of course, to use Rails also on top of our testnet. As Mario mentioned, this is for institutional privacy, so between two different Rails privacy nodes. But you can test it definitely, because as Mario said, the resources needed are very small, so you can also test it and modify it and tell us what you think. And what else I want to say about the
I mean, you can
license?
even run it today, right? You can just go
Yes,
on the GitHub,
yes,
go to the GitHub, follow the demo instructions, and you can have almost like your local testnet working right there. But we
absolutely.
will have it available on our official testnet of Rails. It's just a matter of when, as we're polishing a couple of things right now on different fronts.
Okay, and then there was another questions around, basically the enterprise adoption. So this license and how this impact the enterprise adoption. As I mentioned, it's basically the idea and the fact that the enterprise is quite free to use and distribute the code even without open source the complete solution that they're using, again, for their confidentiality. So with the commercial license, they can do this as well. So this is the reason we picked this license in particular, and we wanted to be 100% transparent with you. So today we are explaining not only the technical core of Enigma, but also answering your questions around the license, because we believe it's quite important for everybody to understand what this means, and also for both for enterprises, but also for retail user, like you are interested in knowing more about Enigma, and I think you need to be able to do that. So we are opening that to you as well. Another thing that I would like to mention maybe is talking about the privacy roadmap that we have and the idea of how this would lead us. So we basically talk about what is Enigma, and we explained that Enigma is this kind of umbrella, this framework that we will use, and with which we will have different protocols behind that. So right now we focused a lot around the institutional privacy, because this is where we started working with and where the most demand was coming from. But we realized over time that also there is a lot of requirements and requests also from the retail users to have a privacy that could be auditable, and so could be aligned with the regulatory landscape. So we will work also on some retail solution for privacy as well, planning around similar. Well, the idea is to be very inspired by also what other solutions are doing. And if we think about Ethereum, the idea is like you have your private solution, that is our privacy node, that is our privacy network, so you can have all the private transaction there if you want to, but also have open a channel to the public chain. And this is what we are doing with our privacy node. And with that, what we can do is start also thinking about not only privacy between institutions, but between retail users directly. So it's something that we are working on. We will let you know more in the future. I don't know, Mario, if you want to add something on this, but this is the idea.
No, I mean, that's literally it. The thing I can add though is that since the repo is officially public, all upcoming changes are going to be there. So keep an eye out every now and then, because I'll be adding all the changes. If you want some Easter eggs before Easter, keep an eye out on that repo, because that's going to be updated on a pretty much on a daily basis now, and you will be able to see how DVP works. Because if I were to guess right now, that's probably what's going to be more updated there on that repo. But pretty soon you'll see what our approach is for the Enigma retail payments would be. And there's a couple of questions in the chat as well, and it's important. Every time we think like private tokenization at Rails, it will probably be funneled via Rails Enigma, right? So like if you any questions that you may have like, oh, how are these private payments, private tokenization, private something? If it's private something, most likely it's always going to be an Enigma transaction. And then based on the use case of your question or your what you have, whatever you have in mind, it may be retail payment, institutional payment, or DVP, right? So any questions that the audience may have on how that type of thing will work, it's like 95% plus. It's an Enigma transaction.
Yeah. Also, there are like some questions around, the settlement flow and how it looks like for private and privacy preserving solutions, so for Enigma in general, and how does this scale? So basically, it's I think one of the things that you can talk about is how scalable Enigma is, and maybe we can discuss this a bit, and then we can talk about the settlement flow as well.
Yeah. So Enigma scales very well, and if you think like in number of financial institutions, like we scale linearly in number of financial institutions, which is great because as you can imagine, there's much less financial institutions than actual users. So if you want to scale linearly in something, you want it to be in number of financial institutions. We also allow for a lot of aggregated payments, right? So like not only we scale very well there, we actually have like very fast throughput because you can pay multiple people all at once. And we want to bring all of these primitives onto mainnet so that you see how these financial institutions settle with each other using Enigma, right? So like Enigma is pretty much the de facto standard for all types of settlement flows that require some type of privacy. And honestly, we're also taking an approach where we want privacy almost by default, right? So if we're doing some type of settlement and some type of transactions involving financial institutions, we want that to be using Enigma right away because we care about privacy. It's not, we also don't want to have like this very elegant protocol and then not really use it, especially when a lot of institutions and people can benefit from it, right? So the goal is this is open source now. Like everyone can check the code. You can run it locally right now. Very, very soon, you're going to be able to have it out of the box on the testnet for you to try out. And then when mainnet goes live, which is very soon, it's also one of the questions that was thrown there, very, very soon, that will also be there as like a toolbox for people to use. And then while we're at it, I saw that one of the questions there is also like if we're planning to expand first into emerging markets or more established ones. We have a very peculiar roadmap with a lot of strategic partners. You will get an answer to that very soon. I think you're already getting an answer to that now as you see kind of like the press releases that we're putting out. There's going to be a lot of tokenization announcements. Very, very interesting projects. And we're trying to leverage all of this using Enigma as well as possible. And yeah, it's pretty exciting times ahead.
Quite exciting. The other thing that I would add is the verifiability of things. So basically, it's true that we would like to use privacy preserving solution, but when we talk about, privacy preserving solution, we also need to give a way for other people to be sure that they're exchanging, their money or their token with trustworthy authorities, or they can also be sure that the value behind the token is real. So what we are working on, besides of course the work that we are doing with Enigma, is also this connection between private permission solution and public solution. And in this way, we're using our privacy node that will ensure that whatever is created inside the private permission side can be proven on top of the public chain. This is also helpful for Enigma because whenever you're doing then a transaction with an Enigma token or payment or DVP, you can always be ensured and knowing that that asset is backed by a real value. And you can also, the other thing that I think is quite important for Enigma is that it creates with all the, public key kind of identity layer of overall, the whoever is transacting inside. So you can be ensured and assured that what you're exchanging is real value and it's not fake. So although it's private, it's not that we are not disclosing the information for wrongdoing activity, but more the possibility to to keep your confidentiality and keep your anonymity if you want to, but always trust and verify, just not trust, but verify the overall solution.
Yeah, 'cause it's very interesting how we allow for like this interjurisdictional setting, right? You can have like different silos where there's different sets of rules, like based on different jurisdictions, but then at the end of the day, they can all connect with each other and transact privately and securely and verifiably, right? So like they can kind of like, even though they may be mutually suspicious, at the end of the day, they can verify mathematically that everything is going well in the system, right? And that's very powerful, especially when you think kind of like what the reinvention of money looks like, when you think CBDCs, when you think global tokenization and financial institutions. This is like on point with the requirements that they have.
Okay, so I think we answer all your questions, and if we didn't, please send us a message. We are happy to answer them later. We almost finished our time, so I would like to wrap up this space. We discussed what Enigma is, what are the benefits and the use cases where we used Enigma for, and what we are planning to do in the future to have the possibility to give this possibility to has, but also for you, the fact that we would like to open our code and show it to you is for transparency, for verifiability, and also the possibility to hear your feedback, but also what you can build with that. So we are very, very interested in knowing what do you think about it, and to expand more and more. And this is why open source and open code of our technology is quite important for us, because it's something that we can share with you, and we can get great ideas back to us as well. So again, I hope that we answer all your questions. Please share if you have any other questions around the topic. Myself and Mario, but also the rest of the team, are happy to answer them. If there are any other questions around other topic of Rails, again, share with us. We will share that with the proper team that could help with the answer. Mario, do you want to say something else?
Thanks everyone for tuning in. Do feel free to click that DM button on X. Hit me up if you want to know more. I would love for people to go over the GitHub, try to run it, break it, do everything you can, because that's where the fun is. And yeah, I think that's it for me. Thanks everyone for tuning in. Very excited to bring this progress and more protocols to your side.
Yeah, and just as a reminder, we have another Twitter X space tomorrow for our experience with Bank of England. So if you would like to know more about it, please come and join us.